So hi everyone, my name is Nadia, and today I'm going to talk about how metals and polycyclic aromatic hydrocarbons change in indoor house dust and how that is affected by wildfires. So indoor house dust can contain both organic and inorganic pollutants. So that includes polycyclic aromatic hydrocarbons and different metals like heavy metals, which are known to be toxic. Indoor house dust itself can act as a medium of exposure of these pollutants to the residents living indoors and could potentially pose certain health risks. And with Canadians spending almost 90% of their time indoors, really understanding how levels of metals and polycyclic aromatic hydrocarbons are changing from home to home is important to address any of these health concerns. So indoor house dust has pollutants that can come from either the outdoor or indoor environment. Examples of sources in the outdoor environment include emissions from vehicles, emissions from industrial facilities, and finally emissions from wildfires, which is a focus of this presentation. So with global warming, we do expect to see more frequent wildfires. So to understand the impact of wildfires on indoor house dust is definitely something that's much needed. Currently, there's actually no study that describes how wildfires can influence indoor house dust, and there's also no studies that go really in depth and explain the spatial distribution associated with metals and polycyclic aromatic hydrocarbon levels in indoor house dust depending on the different outdoor sources that are nearby. So my research study exactly addresses this research gap by trying to explain the variability we do see of metals and polycyclic aromatic hydrocarbons home to home based on these different outdoor sources. With my research, we can make better informed health-based policies. We can increase our knowledge on the transport of pollutants from different outdoor sources into indoor house dust, and finally, we can improve wildfire remediation efforts if needed. Another main motivation for this specific study is expressed concerns from residents about returning home and the safety associated with different levels of metals and polycyclic aromatic hydrocarbons, which may remain their homes due to a wildfire. So these residents are from Fort McMurray. Fort McMurray is a mid-sized city in Alberta, and in the summer of 2016, there was a devastating wildfire. So 1 to 2 years after the fire, there were 110 total indoor house dust samples taken from the residential homes and measured for levels of 26 metals and 16 priority polycyclic aromatic hydrocarbons. The reason why they're priority polycyclic aromatic hydrocarbons is that they have some potential to be toxic to humans, and they are environmentally pervasive. So using these samples that were collected previously, I plotted each of the individual homes on this map of Fort McMurray. So I used a geospatial analysis tool called ARCGIS, and I was able to calculate the distances from these individual homes in the pink points to different outdoor sources. So these different irregular polygons on this map of colors of yellow to red represent regions that have been burnt by the fire, with red representing regions of high burn severity and yellow representing regions of low burn severity. What I found when I divided up homes based on homes in fire damaged neighborhoods compared to non-fire damaged neighborhoods is that there were higher levels of 4 specific metals. Arsenic, as shown in the box plot, where the yellow box is higher than that of the gray, thallium, aluminum, and finally vanadium, which also shared similar plots. So these 4 metals are known to be heavy metals, as in they are toxic at low concentrations, but despite them being in higher levels, they are still within safe limits. So these higher levels of arsenic we do see is actually something that was expected. When we measured levels of arsenic and ash in a residential area, compared to levels of ash in the nearby forest that was also affected by the fire, there were actually higher levels in the residential area. So what this means is that something in the residential area was contributing to these higher levels of arsenic. And that something might be the release of arsenic from chromated copper arsenic treated wood. And these treated wood may be used for decks and fences for the residential homes that might have been burnt, leading to these higher levels of arsenic. When we tried doing the similar test of comparing polycyclic aromatic hydrocarbons in homes in fire damaged neighborhoods compared to non-fire damaged neighborhoods as a previous slide, we actually see not really much of an influence from the fire. And this is kind of surprising because polycyclic aromatic hydrocarbons are known to be released from wildfires and other examples of incomplete combustion. And there were higher levels recorded previously in the air. So this also conveys that although we might be seeing higher levels in the air, higher levels in the air don't exactly translate to higher levels in indoor house dust. So with respect to lead, although there wasn't any significance with respect to the fire, we did see higher levels of lead in older homes, as shown in the yellow box, compared to homes that were built more recently. One reason why we might be seeing higher levels of lead in older homes is that homes built between 1960 to 1990 have the chance to have their interior and or exterior being painted with lead-based paint, which could be contributing to these higher levels. When I tried to understand how exactly the fire could possibly be contributing to these higher levels of metals and polycyclic aromatic hydrocarbons, there tends to be relatively weak trends. So the independent variables I looked into to see whether or not they were connected and explain the different concentration levels we are seeing home to home include looking at distance to low, moderate, and high burn regions, and finally looking into something called the spatially weighted burn ratio and trying to see whether or not these independent variables that measure the different effects of the fire actually influence the variability we are seeing in metals and polycyclic aromatic hydrocarbons from home to home. So the spatially weighted burn ratio includes looking into different burnt regions within a 5-kilometer radius circle and its area. So each home has a 5-kilometer radius circle created, and it has its own spatially weighted burn ratio. By considering a larger area, we are able to include a greater influence of the fire. Generally speaking, a home with a lower spatially weighted burn ratio has a lower fire influence, and vice versa for a higher spatially weighted burn ratio. We expect that homes with a higher spatially weighted burn ratio should have higher levels of metals and polycyclic aromatic hydrocarbons. With all of these independent variables we've tested and trying to explain these concentration levels we are seeing changing from home to home, we get fairly weak trends. And when we look into homes in fire damaged neighborhoods compared to non-fire damaged neighborhoods, only 4 out of the 26 metals had shown higher levels, but they were still levels within safe limits. So what this really conveys is that wildfires actually have very little influence on indoor house dust. So this is great for the residents as they don't have to worry about any sort of long-term impacts from the fire on their own health. And we also know that whatever cleanup measures were taken were appropriate enough such that if there were harmful levels at the beginning, there's no longer any more 1 to 2 years after the fire. For future studies to really solidify the conclusions I've made, we should also consider looking at the impact of seasonality on the data. We should consider larger samples and also within a greater span of area. And finally, we should also consider sampling nearby soil and road dust and to compare those concentration levels of different pollutants to that we see in indoor house dust. So with that, I do want to give a huge thank you to Professor Chan and graduate student Marcia Pedrosa for guiding me in this research. Thank you everyone for listening, and I can now take any questions.
Thank you, Nadia, for your presentations. I would like to address the judges and ask if you have any questions. Feel free to unmute yourselves and ask.
If it's okay, I will try to ask a first question here. I have to say I'm astonished by the results of this, and it sounds like you were a little bit surprised as well. Do you have a sense of how much cleaning took place in some of these houses before the dust measurements were made? I mean, you in your next steps, you've got exactly the right thing to do, which is sampling nearby soil and road dust, which presumably hasn't been cleaned. Do you have a sense of how much cleaning was done in the houses, though?
A relative sense, since the residents were given surveys and they were asked to fill out how much they've cleaned after the fire and who they've hired. So most residents did have cleanup crews come, so they did a more extensive and thorough cleanup, while a lot of the residents also did their own cleanup.
Okay, so there was some cleaning done. Okay, but it means it probably was done well, which is really good news.
Yeah, that's great for the residents.
I guess I can ask a question. So Nadia, you may remember from ESP, you took ESP, right?
Yeah.
Okay. So I'm focusing now on just the delivery of the presentation, because I think your research is very solid. You've clearly done a lot of work. How long have you been working on this project?
Since the start of May.
Okay. So the only thing that I was kind of interested in is how, if you had to do this over again in the future, what can you do at the beginning as an opening strategy to kind of draw your audience in and engage them and somehow create that emotional impact for them? And I'm just wondering, what's the number one issue of sort of related to the problem that you're addressing through your research that you think would most interest a broad spectrum of audience members? If you could say it in one sentence or two sentences.
I think probably the main message I would like to get across is regards to how indoor air quality is impacted by wildfires. And I think that if I could move that to the very beginning where I talk about the residents in the first place, there's going to be that emotional connection that people can relate to as well.
Yeah, exactly. And you can even push that further and concretize it with numbers, 10,000 people's quality of life or whatever. But yeah, you definitely, I would suggest in the future, trying a hook. And what I'll do is I'll send you through Messenger some strategies and examples from PhD students here on how to start this presentation with more of an emotional impact. Otherwise, congratulations. Excellent work.
Great. Thank you so much for the advice. I can take questions from the audience if you'd like as well.
We're on time right now, actually. Okay. We only have 3 minutes for Q&A, but there is a questions for presenters channel that everyone, like the audience, can go to, and they can @ you and you can follow up with your answers. So we definitely encourage everyone to go there. There already have been some people asking questions there. So that's there.
Okay, thank you so much.
Yeah, thank you so much, Nadia. Is